We have seen how the maximal margin hyperplane can be found when the xi's are separable by a hyperplane. If the xi's are not separable by a hyperplane, we can still try to find a hyperplane that separates most of the points, but that may have some points that lie inside the margin or lie on the wrong side of the hyperplane. Here's what such a scenario might look like. Okay, so here you can see that one of the orange x's is on the wrong side of the hyperplane. And this one here it's on the correct side, but it's inside the margin. Okay, and this one is on the edge of the margin. The method we will look at is called the support vector classifier, also called the soft margin classifier, because the margin can be penetrated by points from either side. Just as in the case of the maximal margin classifier, we want our hyperplane to be as far as possible from each point that's on the correct side of the hyperplane. So points on the margin or outside the margin but on the correct side of the hyperplane will be as far as possible from the hyperplane. Points inside the margin but on the correct side of the hyperplane will be as far as possible from the hyperplane and as close as possible to the margin boundary. For those points on the wrong side of the hyperplane, we want those points to be as close to the hyperplane as possible. Let's take a look at this graph. Okay, so here I labeled one of the points x1. x1 is on the margin, but it's on the correct side of the hyperplane. Okay, x2 is outside the margin, but on the correct side of the hyperplane. x3 here is inside the margin, but on the correct side of the hyperplane. And x4 is on the wrong side of the hyperplane. Okay, let's make all of this more precise. In the discussion of the maximal margin classifier, we've seen that the perpendicular distance between xi and the hyperplane beta naught plus beta 1 x1 plus dot 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 plus beta p xp equals to 0 is given by this expression here. So 1 over the norm of beta times this if this expression is positive, and negative this if this expression is negative. So the signed perpendicular distance between xi and the hyperplane is given by 1 over the norm of beta times y sub I times beta naught plus beta 1 xi1 plus dot 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 plus beta p xip. Okay, this expression is positive if xi is on the correct side of the hyperplane. It's negative if xi is on the wrong side of the hyperplane.